In section 2.4, we're going to talk about quadratic equations. Now, these are the ones that begin with a squared term, a variable that's squared. And a quadratic naturally can't be solved as a normal equation because you have x squared, not just x. So it's necessary for us to factor it, and then we move everything to one side. We get all the non-zero terms on one side. We have factors, and if the factors, one of the factors is equal to 0, then that's a solution. So in a quadratic, you usually have more than one solution. Now let's take a look at the first one. Has already been factored for us and set to 0, which is the requirement of being able to solve these equations. And so if either one of these factors were equal to 0, then the equation would be true. It'd be a true statement. So what we do is we set them to 0. We set the first factor to 0, and we set the second factor to 0. They're binomials. And we'll solve. So this one is going to be -4 because I subtracted 4. And here I'm going to have to do a little more work. I'm going to add 3 to both sides, and then I'm going to divide that by 4. So I'll have two solutions. -4 and 3/4 would be what would make this statement true. So those are two solutions for this equation. Let's take a look at the second one. It's also been factored for us, so we've already kind of taken that step. Let's go ahead and set those factors equal to 0 because both the product of those factors is equal to 0. And x minus 10 equals 0. And let's go ahead and solve. We'll subtract 9 from both sides over here. And then we can divide by 4. So the first solution I find is -9/4. And the second solution is a lot simpler to find. I simply add 10 to both sides, and the second solution is 10. Now, more common, what we find is that the equation that we want to solve has not been factored. That's the example that we're looking at right now. So you've got to decide on a factoring method, and you should have learned a lot of these in your last class. And we won't be teaching you factoring here. There's something that you're expected to be proficient at by the time you get here. So basically, though, in this type of solution, in this type of quadratic, we have to get everything to one side and have 0 on the other side, and then we can factor. In this one, I'm going to have to move that positive 30. I'll subtract 30 from both sides, and now I have it set to 0. So now I can look at it and say, okay, can I factor? Usually, the simplest method is to check and see if it factors first before you do anything like the quadratic equation or anything. So let's check this one. The minus says I need one of each sign, and I'll have x as the first term here. And I'm looking for factors of 30 that subtract to give me 13. And what most people look at that and see is 3 and 10, because 3 and 10 would combine to give me 13, but they add to give me 13. They do not subtract. And that second operation says they have to subtract. So I got to look for other factors of 30. 1 and 30 doesn't work, but 2 and 15 is what I would try next. And 2 and 15 does work. It needs to be a -13, so the bigger number has to be negative. And I'm going to do some checking on this. X times x is x squared. 2 times -15 is -30. Inside is 2x minus 15x. That would give me my -13x. So I have my factors right. And now I can finish the problem by setting each of those binomial factors to 0 and solving. So I've got an x equal -2 and an x equal positive 15 as my two solutions. Let's go down to number 2, which is already semi-factored on the right side, but I've got terms on the left side I've got to combine. So really the work that's been done in pulling out this greatest common factor has to be undone before I can finish this problem. So I'm going to get everything over here first to the left side and make it just equal to 0. But at the same time, I'm going to distribute this multiplication back because I know I've got to have those terms combined before I can take everything together and refactor it. So I'm going to say 6x times x is 6x squared, and 6x times a -1 is a -6x, and then I plus had a positive 1, and then let's go ahead and say minus 22 and plus x equals 0. I got everything over here to the left, and that helps me. I know I have a x squared term. There's only one of them, so it's the first term. The next term needs to be my x variables. I've got a -6x here, and I've got a positive x, so it's really like negative 6 plus 1, so that's going to be a negative 5x. And then the last thing I've got is 1 minus 22. 1 minus 22, of course, is a negative 21, and that's equal to 0. Now, I would look for a GCF as my first step, but there isn't one. 6 and 5 have nothing in common that I can factor out. So I know I'm going to look for factors, and I know I have one of each sign, and I know that there is an x variable in the first term. But now I'm going to go to one of my other methods for factoring a complex trinomial, something that has a coefficient of the a term that can't be factored out. And my method, the method I really prefer, is the diamond method. I say 6 times negative 22. Well, that comes out to be kind of a big number. It's negative 126 up here. And then I say the b term, I'm sorry, it was 6 times negative, 6 times 21 is what I was looking for, right? And that's, of course, where I got that negative 126, 6 times negative 21. And then the b term is a negative 5. So I've got that set up. Now let's set up the factors that I'm going to have over here. I'm going to put that a coefficient and the x variable. I know I need one of each sign, so I can figure out what my factors are here. I need factors of a negative 126 that will equal 5. Will subtract and give me 5. So they're going to be an interesting set of factors, but I don't know them, so I'm going to kind of come over here and go 126. Well, 1 and 126 do not have a difference of 5, do they? How about 2? 2 goes into it, so I have 2, and that would be, what, 63? Still not a difference of 5 there with that one, is there? And I would keep going with this. I would say 3 would go into it. I think it's 42. Still not a difference of 5. I'm going to have to go up a little bit further, and as you're seeing, this doesn't take long to do if you're using a calculator. You just keep saying, okay, 1, 2, 3, 126 divided by each of these, and see if there's a difference of 5 in the two factors that you're working at, because this is numbers that we're not going to know right off the top of our head. So then I look for 4, but it doesn't divide in there. 5 doesn't divide into 126. 6 will, though, and so if I say 6, I know that's going to be 21. Right? I knew that one. But there's not a difference of 5 there. So 7 I would check, and then 8 I would check. I'm not finding them here, but I'm going to see what's the next one I find. I find 9. And 9, when I did this factor, 9 went into 126 14 times, and that's where I found the combination. So you see, I only had to go up with my calculator. It didn't take me too long. And then this does have a difference of 5. I need it to be a negative 5. I need the bigger number to be negative. Okay, so that's where I'm going to put them, over here in my factors, because there's still something that might have to happen. I may need to reduce them. And so the 6 and the 9 will reduce. I'll divide them both by 3, and that will be 2 over 3. So what I have is 2x plus 3. That's first factor. And then this one, both of these can divide by 2, so that would be 3. And this would be 7. Whoops. So I've got 3x minus 7. All right, let's check them. 2x times 3x is 6x squared. 3 times negative 7, negative 21. Inside, that's a positive 9x. Outside, negative 14. Well, negative 14 plus 9, that's going to give you my negative 5. So it does check. And now I can set each of these binomial factors equal to 0, and all I have to do is solve. Well, subtract 3 from both sides, divide by 2. Add 7 to both sides over here, and divide by 3. So the first solution is negative 3/2. The second solution is 7/3. Okay, let's take a look at this third problem. And I've given you a bunch of practice here, so probably more than you need, but it's good to practice and get really good at factoring before we go into what we've got to do next. So I'm going to take and do what I did before. I've got to get everything over to one side. I'll choose this side. It has most of the terms anyway. And I need to get everything together so I can factor it again, and I'm going to end up distributing to do that. So I'm going to say 12x times 6x, well, that's 72x squared. And 12x times negative 10 is going to give me a negative 120x. And then I'll add 50 to both sides. So I'm going to have plus 50 here equals 0. Now, I hate factoring numbers this big, so if there's any way I can get a GCF out of them, I will. And I know they're all even, so at least a 2 would factor out. I could check some other numbers and see if bigger numbers would come out. I would try 3, 4, 5. 3 would work for 2 of them, but not for another one. And 5 doesn't work for all of them. And it looks like 2 is it. Let me try it. If I factor out a 2, I have 36x squared. And that would be minus 60x and plus 25. And I look at the result and I say, okay, can I get anything else out of those? Do I have the only factors of 25 are 5 and 5 and 1 and 25, and those are not factors of the other 2. So I'm done, and I can now factor that trinomial. It's going to be a complex trinomial to factor, so I'm going to go back and try my method again, except I see something special. This time, I noticed that this first term is a perfect square. It is 36 is a perfect square, x squared is a perfect square. The square root of that is 6x. This last term is also a perfect square. The square root of 25 is 5. So this could be a perfect square trinomial if the product of the square roots of these two terms doubled is equal to a negative 60x, and it is. So I'm going to go ahead and factor it as a perfect square trinomial. Now, try it out and see. 6x times 6x is 36x squared. Negative 5 times negative 5 is 25. When I do inside, I get negative 30x. Outside, I get negative 30x. That adds to be, or combines to be, a negative 60x. And that's what you check for. If you have a perfect square, look to see if this is the two square roots multiplied together and then multiplied times 2. And that's what you can tell. And then you've just got really 2 times 6x minus 5. You could say squared up here, couldn't we? So I really have two factors, but they're both the same. So it's the same solution. I'll just set that solution to 0 and find out what it is. And I'm doing everything that you know how to do. That solution came out to be 5 over 6, 5/6. Now, on this page, we're going to look at solving quadratics by using something called the square root property. And what we're doing here is we're going to get a perfect square on each side of the equation, or perfect square on one side, and then we're going to, or our variable actually squared, and then we're going to take the square root of that, of both sides, to see if we can come up with solutions this way. Now, the way it works is you take the square root of both sides, and our solution side, our variable side, is equal to plus or minus the square root of the other side. So you usually get your two solutions that way. In other words, this one's already set up for us. X squared is equal to 18, and x squared is my perfect square. So if I take the square root of this side and the square root of that side, and I'll go ahead and put plus and minus on that side because that's required for this to work. When I take the square root of x squared, I get x. When I take the square root of 18, well, what I'm really going to have is plus or minus, and I'll write it again for us, 18, but that's not the simplest form of that. There's a perfect square inside 18. If I were to factor it, it would be 9 times 2. And 9 can be brought out as a 3. The square root of 9 is 3. What's left under the radical is a 2. Now, I'm not going to be writing all this down every time because you're supposed to have gotten good at this at the last class you took. So let's see what that says for us, though, is x is equal to plus or minus 3 times the square root of 2 is my solution. Now, you could plug these back into your equation and check them, which might take us more time than this takes. And I want to spend all our time on seeing if we can get here, get these solutions done for you, okay? Now, the second one says 50x squared minus 72 is equal to 0, but I really don't have the perfect square that I need on one side. I'm going to isolate the variable term. Isolate the expression containing the square term. Well, here's the square over here, is the x squared. We're not going to worry about that 50 just yet. So I'm going to say, I'm going to put it like this. 50x squared is equal to 72. I took the 72 to the other side. Now, I can factor out a 2, and if I do that over here, I have a perfect square. Now, how would I get rid of that 2? Well, I'll divide both sides of my equation by the 2. So that would make this go away, and I would have just 25x squared. And if I divide 72 divided by 2 gives me 36. So now I have a perfect square, and that's what I was working for. Perfect square on this side, and doesn't really matter about the other side. So I'm going to take the square root of this one, and I get 5x. And I'm going to take plus or minus the square root of 36, and plus or minus the square root of 36 is, of course, 6. So I still have a little bit of work I can do with this. I can divide both sides by 5, and I'm going to end up with x is equal to plus or minus 6 divided by 5. So we can look at this as two answers. One answer is 6 over 5. The other answer is negative 6 over 5. Let's look at number 3. Perfect square term that I want to isolate is this x squared. So let's move the 121 to the other side. I'll subtract it from both sides, and I have a negative 121. It also happens to be a perfect square if it weren't for the negative out front of it. But let's see what happens when I take the square root of both sides. I'm going to end up with plus or minus the square root of a negative 121. Now I can resolve the square root of a negative 121. I will change this whole thing, and it will be 11i. So what do I have? We'll have x is equal to plus or minus 11i. I resolved the square root of the negative 1 to be I, and then square root of 121 is 11. Let's take a look at the next example we've got is number 4. This time I've got a perfect square. It's maybe a binomial, but that's okay. Let's take the square root of 3y minus 2 squared, and it would just be 3y minus 2. And then let's take plus or minus the square root of 4, which is going to be 2, isn't it? So that kind of was nice. I got plus or minus the square root of 4 being 2, and I'm going to go ahead and see if I can do some more work here. I'm going to get rid of this negative 2. I'm going to say 3y is equal to 2 plus or minus 2. And then I'm going to divide this by 3. And that looks like all the work you have to do, but you can do the math involved here, and it's really easy. So what I can do is I can say, well, one of my y's is equal to, one of my solutions is 2 plus 2 divided by 3, which is really 4 over 3. There's a solution. And let's do the other one with a negative. Y is equal to 2 minus 2 divided by 3, which is 0 divided by 3, which is okay. We can't divide by 0. We can't have 0 as a denominator, but we can have it as a numerator. That solution is simply 0. You can put those back in and check and see that they work, but they do work. Now let's take a little bit more complicated one. Here I've got my squared term is a binomial. I want to isolate it, so I'm going to divide both sides by this 2. When I divide this by 2, I end up with 3 minus x. Whoops, not writing that right. 3 minus x squared. And then I divide the other side by 2. Well, negative 14 divided by 2 is a negative 7. Now, let's take the square root. That means I have 3 minus x, and that's equal to plus or minus the square root of a negative 7. Well, I know the square root of negative 1 is I. I can't do anything about the square root of 7, but I can. I'm going to just circle it to show that I'm going to resolve it this way. I can say this is really the I times the square root of 7, or the square root of 7 times I, however you want to look at it, okay? Sometimes it's easier for me to see it this way, so I write it like this. Now, I've got that, took care of this this term here, this variable here. So I'm going to say now I want to isolate this negative x, or I want to isolate the negative x, the variable. I'm going to subtract 3 from both sides. This is a negative 3 plus or minus I times the square root of 7, or the square root of 7 times I, either one. And let's divide everything by this negative, okay? So negative 1, negative x divided by negative 1 is that. It's just x. Negative 3 divided by negative 1 is 3. Now, there's two different things here. A positive term divided by a negative is going to give me the negative term, and the negative term divided by negative is going to give me the positive term. So basically, I'm still going to end up with a positive and a negative term. It didn't change anything. It just flipped them, but they're still both there as solutions. And I hope that makes sense to you. But those are my two solutions, 3 plus square root of 7i and 3 minus the square root of 7i, or I times the square root of 7. Okay. Number 6, I've got the squared term that I want to isolate is that binomial x plus 5 squared. So I'm going to divide both sides by 2, and I end up with x plus 5 squared equals 20. Now let's take the square root, and we end up with plus or minus the square root of 20, which there's a perfect square inside 20. It's 4. If I were to factor 20, it would be 4 times 5. And this one is going to come out as a 2. Square root of 4 is 2. 5 will have to stay under the radical. And that's kind of how I do it, just to show what I'm doing. I'm going to end up with x plus 5 is equal to, I have to put plus or minus still, and because the 2 is right there in front of the square root of 5. Okay? Now, I need to get this 5 to go to the other side, so I'll subtract 5 from both sides. So x is going to equal, now I'm going to go ahead and put it in front because that's where I usually put it, negative 5 plus or minus 2 times the square root of 5. And that is about as simple as I can get my answer. Now, this next page is talking about the quadratic formula, or the quadratic equation, which when you cannot factor it using one of your other methods, this is what we do. I've seen students jump to the quadratic way too often. It's so much faster usually to factor a simple quadratic equation using another method, use the diamond method or something else that you're used to, completion of the square, whatever you're used to. But this one is a last resort. When it will not factor another way, this is what we use. We use the quadratic formula, or the quadratic equation, sometimes we call it. Now, it's got to be memorized. If you haven't already, you should memorize that x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So what I have to have it in, though, to make it work, is the equation has to be in the form of ax squared, that's a squared, plus bx plus c is equal to 0, okay? It has to be in that format. This first one is not, but it's easy to get it there. We say 2x squared minus 6x plus 1 is equal to 0. So I've got it set up, and I'm going to assume, since they're telling me to use the quadratic, that it doesn't factor any other way. I could see that it doesn't really kind of quickly. I'm going to say a is equal to 2, and b is equal to a negative 6, and c is equal to 1. It just helps to have it written down so that you don't make any mistakes. So what is x? Well, x is going to equal to a negative b, a negative 6, if you want to think about it that way, is positive 6. And then I've got plus or minus the square root of b squared, which is a negative 6 squared, minus 4 times a, which is 2, times c, which is 1. All that's under the radical. And all of this entire side is over 2 times a, which is 2. Sometimes it's a good idea to write it all down and check it before you go on doing the math, because it gets complicated from there. So now what do we have? Well, we have x is equal to 6 plus or minus, and this is 36, right? I'm going to write it out here. 36 minus 8, isn't it? 36 is negative 6 squared, and this is a negative 4 times 2 times 1. Well, that's going to be minus 8. Well, what is 36 minus 8? When I do that, I come up with the square root of 28. And all of that is over 4. 2 times 2. All right, can we simplify anything here? 28 has a perfect square inside it. It has 4. So if I were to factor it, it would be 4 times 7. Now, I can't do anything about the 7. It's going to stay under the radical, but this is going to come out. It's going to come out as a 2. I'm not sure where to write it so that it makes sense, but it goes right in the front of it. So I've kind of jotted a note to myself to remind myself to bring it out. And I'm going to say x is equal to 6 plus or minus, and it's going to be 2 times the square root of 7, and all of this is divided by 4. Now I've got three terms, 1, 2, 3, and I would have to reduce all three of them together, but they all three are even. They'll divide by 2. If I divide this by 2, and I divide this by 2, and I divide this by 2, I have a simpler solution. 3 plus or minus the square root of 7 over 2. Let's do the next one, number 2. It's already in the right format, so all I have to do is figure out what's A, what's B, and what's C. Well, A in this one is 1, B is 7, and C is 3. So I've got X is equal to negative B plus or minus the square root of B squared, which is going to be, let's go ahead and say 7 squared minus 4 times A times C. I like to write it all down first just in case I can check it. Times 2 times A. And then I can check what I've written down before I start doing the math to make sure I filled everything in correctly. Now X is going to equal negative 7 plus or minus, and now we can simplify this a little bit, can't we? This is 49 minus 12. Well, okay, 49 minus 12, I can say that gives me a 37, doesn't it? Now, 37 is prime, and there's nothing that I can factor out of that. Everything, by the way, was over the number 2. So I'm pretty stuck with the square root of 37 over here. So what's my solution? Negative 7 plus or minus the square root of 37, all divided by 2. Now, the next type of solution for quadratics that we're going to look at is called completing the square. Now, completing the square is usually done if we have a binomial that we get a binomial, and then we take the half of that b, the coefficient to the b term, and square it, and then we add that to both sides of the equation. That gives us a perfect square trinomial on the left-hand side, or on one side, the side that we started out with the x square on. So I've got some steps written down. If you're not familiar, you haven't, you don't remember this, go back over these steps, okay? More information is also in your textbook on page 131 about this. And let's take a look at these examples that we've got here. First, I don't want to complete the square with the 6 over here. I'm going to get the 6 to the other side. I'm going to start out that way. I'm going to say x squared plus 7x is equal to a negative 6. And then I'm going to take half of, I'm going to say 7 divided by 2 squared, and I'm going to add that to both sides. So in other words, I take this b term, the b coefficient, and I divide it by 2, and I square it. And I added that over here, so I also have to add it to the other side of my equation. Okay, so on the left-hand side, I have got a perfect square trinomial. I mean, I know it's not pretty, but it is a perfect square trinomial. So I can take the square root of it, and I will end up with a binomial. That's good. That's what I need. And over here on the right, I'm just going to have to figure out what in the world negative 6 plus 7/2 squared is, or what that equals. So I'm going to do some work on that is what I'm going to do. I'm going to say this is, as a perfect square trinomial, it would be x plus, if I factored it, 7/2, and that would be squared. And that's how I would have factored it. It would have been x plus 7/2 times x plus 7/2. So that's my perfect square trinomial. That's the whole reason for completing the square. Over here, I've got 7/2 squared, which is really, I'm going to jot it down, 49/4, isn't it? So I want to write both of these as fourths. I've got 49/4. What's a negative 6 in fourths? Well, it's going to be something over 4, right? And it's negative. So how did I get it? Well, I multiplied 1 times 4. So I'll multiply 6 times 4, and I get negative 24/4. And then I'm going to add 49/4. Because I need to get this simplified down to just one number, don't I? So what I've got is 49 minus 24 over 4, right? So what is that? 49 minus 24 is going to equal 25 over 4, right? Okay, so what I've still got is my perfect square trinomial factored over here on this side. So now I've got it simplified. And I can take the perfect square I've got on the left, and I can take the square root of that, and I can take the square root of this one, plus or minus it, and I can set my solution. So let's do that over here. I'm running out of space. I'm going to take the square root of the left. I get x plus 7/2. And that's equal to plus or minus the square root of 25 over 4. Well, it just so happens that that fraction, both the numerator and the denominator, are perfect squares. So that's really 5/2. I can take that and resolve that radical to 5 over 2, can't I? So what have I got as my solution? Well, I've got x plus 7/2 is equal to plus or minus 5/2. Okay, that's pretty simple. Let's move this 7/2 to the other side. We'll subtract it. I'm going to say x is equal to a negative 7/2 plus or minus 5/2. Well, now you recognize this as being two possibilities. The first one is that x is equal to a negative 7/2 plus 5/2, which is going to be like a negative 7 plus 5, which is going to be negative 2 over 2, right? I would do the work with the numerators, keeping the sign in the numerator, so it's really negative 7 plus 5, negative 2. Denominator was the same, and that's really negative 1. So there's my first solution. And the second solution is, of course, going to be x is equal to a negative 7/2 minus 5/2. So I know my denominator, and my numerator is negative 7 minus 5, which is negative 12. So when I do this division, negative 12 divided by 2, I got negative 6. There's my two solutions for it. It's going to be a negative 1 and a negative 6. Let's do another one of those, because these do get to be a little tedious. They're not really complicated, but they're tedious, and you do have to be careful. So for this one, I've already got my binomial, my x squared and my x term over here. The only thing that I don't have is that this first term has to have a coefficient of 1. Well, it has a coefficient of 3, so I can't start until I have taken care of that. I'm going to divide everything by that coefficient of 3. I know that ends up with a bunch of fractions, but it's okay. I end up with x squared plus 5/3 x, and that's equal to a negative 2/3. Now, I want to complete the square over here. So what I have to do is take 1/2 times 5/3 and then square it is what I have to do, right? And that's the only way I can get that to be to complete the square on that side. Now, if you're not used to working with fractions, this is a really good time to get used to it, because we've got a lot of that work to do this semester together. So I'm going to say, what would I do? I would say 5/3 times 1/2. Think about that. 5/3 times 1/2, right? And all I do is multiply numerators, multiply denominators. It's really 5/6. It's not that complicated. So I've got x squared plus, I still have that b term. And then I'm going to add to that 5/6. And what was the rule to it? I have to square it, right? 1/2 of the b coefficient squared, and there it is. If I do that to the left-hand side, though, I got to do the same thing over here to the right. So I'll add 5/6 squared. Now, over on the left, I have a perfect square trinomial. Let's go ahead and factor it like that. So it's going to be x plus 5/6, and it's going to be squared, isn't it? Perfect square trinomial. That plus sign tells me to look at the first sign for both factors, and the first sign is positive, so they're both going to be positive. Now look at, that's got that perfectly ready to go ahead and take the square root. We're going to have to simplify this side, though. I've got 5/6 squared, which is really going to be 25/36, isn't it? So if I've got 25/36, I need to represent this negative 2/3 as 36th, don't I? So I'm going to say, okay, how do I get that 3 to become a 36? I multiplied times 12, didn't I? So I'm going to multiply my 2 times 12, my negative 2 times 12, and I get a negative 24. Okay, the 5/6 squared already said that's going to be 25/36. 36. I got the same denominator finally. So what I've got here, I can go ahead and say, is really on this side, I've got negative 24 plus 25. That's going to be 1 over 36, isn't it? I'll rewrite it because otherwise I'm getting confused. Now, take the square root. Square root of the left is going to give me x plus 5 over 6. When I take the square root of the right, I'm going to say plus or minus. The square root, can we just do it like this? Square root of 1 is 1. Square root of 36 is 6. So it's plus or minus 1 over 6. I'm showing you a few little shortcuts that you might want to utilize if you can do them. Okay, so x plus 5/6, let's subtract 5/6. I've got a negative 5/6. And it's plus and minus, plus or minus 1 over 6. So I've got two solutions. X is equal to a negative 5/6 plus 1 over 6, which is going to be, what is that one going to be? Well, I would say 1 minus 5 would give me a negative 4, wouldn't it? Over 6, which is going to be a negative 2/3. And let's do the other one over here. X could equal that negative 5/6 minus 1 over 6. Well, they're both negative, so I'm going to say negative 5 minus 1, right? That's going to give me negative 6 over 6, which is going to be a negative 1, isn't it? So I got two solutions, negative 2/3, negative 1. I'm giving you a few more examples because this can be a little tricky, but I would try all of these if you're watching this on the tape. If we haven't done these in class, I would try them and then come back and see if you got the answer right, okay? Because now I'm not doing anything different. I'm just doing the same thing over and over again. First, I want to set this up so that I can get a binomial over here that I can complete the square with. So I'm going to say 9x squared minus 6x. And I'll take that 1 to the other side by subtracting it, so I'll equal a negative 1. I have to have a coefficient of 1, so everything here has got to be divided by 9. I'll go ahead and write it down so I can see what I'm doing. When I do that, I end up with just x squared minus, can we go ahead and reduce that one? It would be, divide both of them by 3, wouldn't it? So I would say that's 2/3 x, and that's equal to a negative 1/9. Okay, now I've got it set. Let's take half of 2/3 and square it, okay? 1/2 of 2/3 and square it. So here I'm going to write these two terms down, and I'm going to add 1/2 of 2/3. 1/2 times 2/3 is 1 times 2, and 2 times 3. And then I square that, right? And that's equal to negative 1/9 plus 2 over 6 squared. Now, most of you saw that that could have been reduced, and that's what the next step would have been, right? Let's reduce that. So I've got x squared minus 2/3 x plus 1/3 squared, right? And this is equal to, let's see, it's going to be a negative 1 over 9. And that's going to be plus, we'll just write it down like it's supposed to be, and we'll take care of everything else later, okay? So let's go ahead and factor this one because I have a perfect square trinomial. This plus says both sides of the factors have to be the same. This time they both have to be negatives. And I'm going to take the square root of both the first and the third terms. And next I'm going to say that squared is equal to, now this is going to be negative 1/9, and this is going to be a positive 1/9, right? This is really, this 1/3 squared, I'll scratch it out and fill in, it's really going to be 1/9. So what is negative 1/9 plus 1/9? Well, it's really 0, isn't it? Okay, so I'm going to take the square root of the left, and I get x minus 1/3, and that's equal to the square root of 0. Let's just add 1/3 to both sides. This time it sort of turned out to be a little different. My answer is 1/3. And there was only one answer. Okay, number 4. First, we have it not in the right shape. We need to get this x term over here with this x squared term. So I'm going to rewrite the equation. I'm going to say that's really 6x squared minus 13x, and that will equal 8. And now I have to get this x squared to have a coefficient of 1, so I have to divide everything by that 6. And I end up with x squared minus, once again, I'm working with fractions, and that's equal to, I could go ahead and reduce this one though, divide them both by 2. It might help me later, it might not. All right, now let's see what we've got here. I want to take half of this and then square it. Well, I'm going to go ahead and write down x squared minus 13 sixteenths, x. And then I'm going to say it's going to be added, because we always add it. And 1/2 of 13 over 6 is really going to be 13 over 12 squared, right? Okay, and that's equal to the 4/3 plus, same thing, 13 over 12 squared. Okay, let's go ahead and factor this because we have a perfect square trinomial. It's going to be x minus 13/12, and that's binomial squared. That's my perfect square trinomial factored. Now over here, I need to get these fractions to a format that I can combine them. And I'm going to do a little work with them first. This 13 times 13 is 169, and 12 times 12 is 144. So I sort of replaced that. I'm going to go ahead and say I want to add to it this fraction. So it needs to have a denominator of 144. Well, 3 times what to get to 144 is what I have to say. And it ends up being 3 times 48. So 4 times 48 is going to give me my numerator here, 192. How did I find that out? Well, I took 144 and I divided it by 3, and I saw what I had to multiply times 4 to get to the numerator. Hopefully that's not hard for you. So now I can combine these two fractions, because I replaced them both with these two fractions, by saying 169 plus 192, just adding those numerators, right? And when I do that, I get 361. So I want to take now the square root. I'm not going to simplify that because I don't know what might happen here. I'm going to take the square root of this side and make it equal to plus or minus the square root of 361 over 144. Now, you remember that when you've got a fraction under a radical, it's the same as having the numerator as a radical and the denominator as a radical. So I can look at that and say, are these perfect squares? Well, 361, if I take it and check it in my calculator, has a square root. It's 19. 144 has a square root. It's 12. So this resolved into 19 over 12, that radical I just got rid of and put 19/12, okay? So what have I got? X minus 13/12 is equal to plus or minus 19/12. Okay, so now let's add 13/12 to both sides. And there we have our two solutions. We just have to do a little more math to see, because we can come up with exact solutions to this one. X is equal to 13 over 12 plus 19 over 12. I'm just going to add those numerators and put it over that denominator, common denominator. So 13 plus 9 is going to give me 32. Is that right? Which I would then reduce that, right? So I can divide both of those by 4, can't I? So I've got 8 over 3. Okay, let's do the other one. X is this time equal to 13/12 minus 19/12. Well, that means X is going to equal, I would say, over this denominator of 12, 13 minus 19 is going to be negative. It's going to be a negative 6. And that reduces as well to a negative 1/2. So my two solutions are 8/3 and negative 1/2. I have one more problem like this for you, and it's already set up in the correct format. It's really set up for us with the a and b term over here on the left, but all I'm going to have to do is divide everything by the coefficient. In order to get a 1x squared, I would divide it by -3. Therefore, I have to divide all the terms by -3. And I end up with x squared, and that's going to be 6 minus divided by -3 is a -2x. And that's going to equal to a negative divided by negative gives me a positive 5/3. Okay, so the rule is I want to take and turn this into a perfect square trinomial. Let me just go ahead and write it down. I want to take half of -2 and square it, right? I'm going to take half of this and square it. I'll add it because sign's not an issue with this thing. So I'm going to say half of it is a 1, and a 1 squared is really just a 1, isn't it? I'll write it like that. And I'm going to have to add that 1 squared over here to this side as well. So let me go ahead and factor my perfect square trinomial. It's going to be x minus 1 squared. Remember, when we're factoring a trinomial that has the second operation is positive, you use the first for both of the factors. That's why it has a negative in there, is because that first operation is negative. Go back and look at your how to factor or how to complete the square, okay? All right, and here we've got 5/3 plus 1. 1 squared is just 1. How many thirds is that? Well, it's 3/3, isn't it? Or in other words, that's going to be 8/3. And I'll go ahead and say square root of this one plus or minus the square root of this one, right? Now, I got a bit of a problem. I have a radical in the denominator. I have a radical in the numerator too, but I can always leave it there if I need to, but I can't leave a radical in the denominator. But first, let's go ahead and get rid of this -1 over here. I'm going to say x is equal to 1 plus or minus, and I'm going to write this a little differently. I'm going to separate out my radicals because I know I've got to do some work here. What have I got to do? I've got to get rid of the square root of 3 in the denominator, so I have to multiply times the same thing. And if I'm going to multiply the denominator of that fraction by that, I have to multiply the numerator. So what happens is I have in the denominator square root of 3 times the square root of 3, that's just 3. And then when I say the square root of 8 times the square root of 3, what I've got is the square root of 24. And now I look to simplify that square root of 24. Can I factor it into any perfect squares? Well, it has the perfect square 4, and that would be times 6. So this one can come out from under the radical, right? Let's go ahead and do that. X is equal to 1 plus or minus, it would be square root of 4 came out. It's a 2 times the square root of 6, and that is over a 3. I can't seem to simplify it anymore. That seems to be my answer.